So we are using nonlinear resonance to help detect flaws that are at the microscopic level, so micro cracks that you can only see with complex machines like X-ray CT. This is a novel patented technique that should help set AM industry in particular alight.
Theta is developing a test system that uses nonlinear acoustics to be able to detect smaller flaws and defects in samples than are typically detectable. It compares to conventional current methods by being a much more rapid system. It's also able to detect flaws that are smaller, so you're going to have safer components with smaller flaws in them that you would be able to find normally.
Any industry that has no tolerance for failure needs to consider using nonlinear acoustic NDT, whether that's because of safety, such as in the air or below the sea or whatever, or simply because if something fails it's irrecoverable, perhaps because it's gone into orbit. But then beyond that, yes, if you are concerned about the brand value of your product, reliability and so on, then yes, you should also want to have 100% certainty of the integrity of the component you're using.
Non-destructive testing is really important because it allows us to prove that a component that's going into a critical application, like maybe on an aircraft, won't fail in use. Whilst more traditional components made using metals might be easy to inspect, as techniques develop, like 3D printing or composites, non-destructive testing is important because the defects that occur in those processes can't be seen easily. These technologies have developed a unique non-linear acoustic non-destructive testing technique that allows us to explore components of all sorts of different shapes and really complex components that can't be seen using conventional ultrasound or X-ray. We have techniques that are really fast and techniques that can look deeply inside a component to find a flaw, and flaws which are smaller than other techniques are capable of distinguishing.